Assalamualaikum warahmatullahi wabarakatuh. Uh, Berdasarkan arahan terkini yang telah dikeluarkan oleh HGA, maka kelas pada minggu ini akan dijalankan secara online. So, kelas pada pagi ini BQS502 3B. I believe we already talked about superstructure. Okay. About frames, I believe we already done this type of presentation. So today we move on to the types or the material being used for the creation of superstructures. Sorry for the delays and all. This is my first time using Facebook Live for presentation. The first material that's being used for the creation of superstructure is the reinforced concrete. So these are the contents. The reinforced concrete is basically a mix of concrete which reinforcement bars or rebars or other types of fibers has been included or incorporated to strengthen the material. This is because concrete in itself, or what we call as mass concrete, on itself is very brittle. So it can only handle compression, but it cannot handle tension. So in order to overcome the shortcomings of this reinforced concrete, so we have to put in rebars, because rebars, which is made out of steel, is great against compression and tension. So the elements of reinforced concrete, we have the concrete itself, depends on the grade, and then the reinforcement and formwork to produce the shape of the RC. So the design of superstructures, depending on the type of superstructure being used, the loading, or what you call the load from the dead and live and wind loads, would occur at many points of the superstructure. So these loads, which can be hundreds or even thousands of tons, can, it must be transferred safely from the superstructure down to the substructure or the foundation of the building. So therefore the superstructure and substructure, even though being built in different times, must be functioning as one unit. Okay. So the advantages of using RC frames, we have greater flexibility in planning and design, because reinforced concrete comes in semi-liquid form. So we can produce a lot of different types of shapes to construct our building. Okay, so this is very flexible in terms of the project planning, the project design, because the RC frames would follow the shape of the formwork itself. No mechanical lifting plant needed as for steel structure, yeah, because the steel structure is basically a dry construction, and it needs a lot of lifting, but it doesn't mean that the concrete does not need any type of lifting. Instead of using, sometimes they use cranes to lift buckets of concrete into position. But if we are dealing with a lot of volume of concrete, we might want to use a concrete pump. Number 4, is mentioning about the characteristics of concrete, which is weak in tension ataupun regangan. So this can be resolved by introducing steel reinforcement. So we have a lot of types and shapes of reinforcement being put in to the concrete component itself. Lighter in weight, I'm not really sure what does this mean in terms of the weight, because if we compare steel structure and RC structure, which have the same type of dimension, designs and whatnot, usually the RC structures would be a lot heavier than the steel structure. So more economical in the right design, even though it has a lot of strength and whatnot, if the engineer is careful in his design, he can come up with very standardized and cheap design to produce RC frame superstructure. So the disadvantages of RC frames. Number 1, of course, weather. May hinder the progress of construction, because as we know, normally when we talk about RC, we are talking about wet construction, which means that the reinforced concrete has to be batched in situ. So and I'm not referring to one of the newer types of precast concrete construction. This is more of referring to the in situ type of RC structure. And then freedom to cast concrete into any shape. As I've said earlier, the concrete itself is basically semi-liquid, so it will take the form of the formwork that we are using. So the inherent rigidity of concrete frame can be a disadvantage, as it's less able to accommodate any movement. This is true, because RC frames are inherently rigid, very rigid structure. The joints between the columns, the beams and all, they are very rigid, not flexible at all. It won't entertain any type of movement. So in regard, if there are any massive types of movement, especially horizontal movement, if that movement exceeds the rigidity of that joint might fail. So in areas where there is a big risk of earthquakes and tremors, the RC frames which are being constructed without considering these factors will ultimately fail. So that's why for very tall RC buildings which are being built in earthquake-prone areas, they would put like bearing pads under the superstructure to give the RC superstructure a little bit of flexibility in terms of horizontal movement when there are any earthquake happening. And of course, a wet construction meaning that we have the ingredients of the reinforced concrete. We have cement, sand, aggregate, and everything has to be mixed up with water to produce the right kind of grade of concrete. All of this work needs to be done usually on site. And then when this wet concrete needs to be placed where it is needed, it is basically wet. It needs time to cure, and this is when we do not want too much of downpour that will affect the quality of the concrete. So in comparison between RC concrete and steel as a building frame, okay, we can see that first of all, in terms of the construction itself, RC frame versus steel frame is between wet construction and dry construction, meaning that the steel frame can be erected a lot faster compared to RC, because RC needs time for the concrete to be cured. And then it's usually being batched on site for the concrete, where the steel frame is prefabricated and assembled on site. RC frame is labor intensive, meaning that we need a lot of people to work on the concrete, especially in terms of batching the concrete, putting it into location, working the concrete along the crevices of the formwork. So we need a lot of labor, and then finishing the surface of the concrete. Whereas for steel, we need a lot of plant, especially heavy lifting plants, and of course we still need manpower, but they are more specialist types of manpower which can handle, who can handle these prefabricated components. Plant or the cranes, which are very important. So because RC is labor intensive, we usually being we just need semi-skilled and general labor to work on it. Whereas the steel, as I said, you need specialists to install the I-beams and whatnot if you want to complete your work quickly. And then there's flexibility in design for RC, because the wet concrete will typically just follow the shape of its formwork, whatever the design may be. Whereas steel frame, it might have a bit of a limited design choice, but these days you can produce whatever design that you need at the factory before putting it on site, because you can work with the factory's designer to come up with whatever components that you need using CAD software. In terms of duration, of course, RC would need longer construction period because of the curing process. And steel, you do not need for that because it comes already, already finished the components. And then RC, we need more tradesmen. We need more concreter, we need more bar bender, we need the people who works for installing the formwork, the supports. There's a lot of tradesmen involved in building just one component of RC frame. Whereas for steel frame, we need less tradesmen. We just need the iron worker to handle the I-beams into position and to install them. Other than that, we might need like machine operator and such. So a lot less tradesmen. So this is a bit of detail on the creation of concrete itself. So concrete consists of cement, which are usually OPC, ordinary Portland cement, and then we have aggregates, coarse and fine aggregates. So if it's coarse aggregate, we can use a lot of material. We can use limestone, we can use granite, and fine aggregate usually is sand. Sand here, we are talking about river sand. We are not usually keen on using sand from the beaches of the sea due to the presence of salt. And then in that mix, we also put in admixtures, other types of chemicals to create certain properties or specialized properties for the concrete. So the process of concrete hardening is what is called as a curing process. This is where the concrete solidifies and hardens after it's been mixed with water and placement due to a chemical process known as hydration. So when the concrete has been mixed with water and put into place where it will not move around anymore, the process of hydration or the curing process will start to happen. So in this process, the water reacts with the cement, and then it bonds all the components, the sand, the granite, the cement. It all bonds together to create a stone-like material. So basically, the wet concrete is basically a wet type of stone. Okay. So the reactions is highly exothermic, meaning that in this chemical hydration process, it generates a lot of heat. Okay, so this depends on the grade of the concrete and also the amount of concrete you are using. And we want to control the exothermic process so that the heat that is generated will not compromise the strength of the concrete. So that's why you can see that when people do concreting, especially on small jobs, they would put a bit of a covering over the surface of the concrete, like some wet rags. For large scale projects, they would use pipes which have in them like ice water to control the heat being generated by the curing of the concrete. Okay. Okay, so this is property of concrete mentioned already. Okay, so the factors affecting the properties of concrete. Okay, we have water to cement ratio. So the ratio between water and cement must be just right. That's why we do not want to have like heavy rains when we pour or during the process of curing, because this will disturb the water cement ratio. The type of cement being used, what kind of cement that you are using. Is it the ordinary Portland cement OPC or rapid hardening, or whatever type of cement that you are using? Type and size of aggregates. The aggregates must conform to what is required by the specifications. How many types of aggregate must be used, must be observed. And then the use of admixture. What type of admixture that you are using to improve properties of the, such as you might want the concrete to be waterproof, so you put in admixture for waterproofing. Or you want the concrete to cure quickly, so you put in admixture for that. Or you want or the concrete might need to be sent or to travel a long distances, so you might want the concrete to, you do not want it to cure quite quickly, so you put in retardant admixture to slow down the process of curing while the concrete is being sent. Okay, and then of course the water itself, the quality of water that you are using will also affect the properties of the concrete produced. So these are some of the grade of concrete that we usually see. Okay, the higher the grade of the concrete, the higher the ratio of cement being used. Okay, like grade 10, 148. Okay, we only have one portion of cement compared to portions of other materials. Okay, for a structural use, we would usually start it at grade, let's see, grade 20 and above. Okay, structural meaning superstructure use, because that's when we start using reinforcement into the concrete. Below than that, like grade 10, grade 15, is you can use it as mass concrete for blinding, for footing, for your ground floor. I mean, if you, even that's the case, you must have a relatively sound what you call the soil that you are going to pour the concrete upon must be really hard, meaning that it is not a problematic type of soil. Then you can use mass concrete for blinding, footing and whatnot, for ground floor. If the soil is problematic, then you have to resort to the use of reinforced concrete also. So for superstructures, we'll start with grade 20, 1 to 4. And it will go higher when you need extra strength, like grade 25 for watertight floors, wall and tanks. This is suitable for superstructure as well as substructure. For precast concrete components, we have to go to the higher grade concrete, like grade 30 and all. Okay, because usually the section of this precast concrete component is quite thin. So we need to use better and higher grade concrete. Okay, so next is cement. Characteristic of cement depends on, so this is how the cement is being produced. The cement we know is being produced at the cement factory. Yeah. So depends on the proportion of compound of the raw materials and the fineness of the clinker. So this is usually a trade secret of the manufacturer, but we have the general idea. So the most common type of cement is the ordinary Portland cement, OPC, and the rapid hardening Portland cement. And then we have other types also: extra rapid hardening, low heat Portland cement, when you need your curing process, the temperature needs to be controlled, so you want to use low heat. And sulfide resisting Portland cement, this is being used usually for concrete works which are going to be exposed to extreme condition of sulfide present, especially underground. Okay, in terms of aggregate, must be strong, must be clean, and then must occupy 3/4 volume of concrete. Okay, so we use aggregate because it's naturally a lot cheaper than concrete, so we use it to keep the cost down and also improve the quality or the properties of the concrete. Okay. Sand and gravel are the most usual type of aggregate, but we can also use other types such as crushed rock. Depends on what you have on your site. If you have a lot of rock formations, then you can use your resources to produce your own type of aggregates. And then blast furnace slag aggregates. This is from the process of iron smelting, where you have your slag at the top of the iron ore being melted. So you just put that away. When it cools down, it becomes something of a rock. So you can crush that to become an aggregate. Okay, so this is the diagram of the slag. Okay, so as I said, we call a site production of iron ore smelting. Okay, I will not go into detail into this because it's just an explanation of the blast furnace slag, not the concrete overall. And then the water cement ratio. Okay, water is added to, it is an enabler. So without water, the ingredients of the concrete will not react with each other. So as an enabler, it is a requirement for the curing process to start that you have water in the mix. And then it also acts as a lubricant in order for the mix to sufficiently being plastic for the purpose of placing and compaction. So plastic here, it doesn't actually mean plastic bag. It's what you call a condition for the concrete mix where it is not a liquid, but it is also not what you call pepejal. Dia bukan pepejal, dia bukan cecair. Is between those two. So there is a condition where it's known as a plastic. Okay, so we need these ingredients to be in a plastic form so that it can properly flow, especially when you are using concrete pumps or you are working that concrete mix to, you want them to go through the nooks and crannies of the formwork and the rebar. Okay, so by adding water, it makes the concrete a little bit more workable. Okay, so we need a reasonable degree of workability. But we do not want to put in too much water because this will affect the strength of the concrete. This is because water occupies space of evaporation. So when the water evaporates, it will create a void in the concrete mix. So we do not want to use too much of the good stuff. Okay. So in terms of workability, this is important because we know concrete is a wet mix, so we need it to be, something a little bit easy for the people to work it with. And then another effect of using too much water, the coarse aggregate will settle at the bottom. So especially when the concrete mix is a bit too liquid, and then you pour it in the formwork, and then you do all your vibrations and whatnot. The coarse aggregate, which is the aggregate itself, which is usually heavier, will start to settle to the bottom of the mix. Okay, so we do not want this. The aggregate must be in a uniform condition throughout the concrete mix. So this process is known as the segregation. Okay, so we do not want the aggregate and the cement and the sand to segregate from each other. A bit too dry, and it's very difficult to handle and to place the concrete where it is needed. Okay, so we need the concrete to be plastic. So in terms of mixing, should be mixed thoroughly. Okay, to ensure that the water has mixed properly across all of the ingredients. In terms of mixing, we can depends on the quality and quantity needed. If it's not too much, we can use the manual method, the hand mixing. Okay, so thoroughly mix minimum 3 times when dry. So the ingredients are being mixed together at least 3 times. Must be used 45 minutes after adding water. So you cannot keep it for long. It must be used, all of it, and is suitable for small works. For machine mixing, by using machine, we can ensure that the ingredients of the concrete are being mixed in a more efficient and better manner, meaning that the mix is being proper. And then we can use a lot of type of machines, from the small volume to the very large volume, and again must be consumed within 45 minutes. So these are some of the mixing methods that can be used to mix concrete. We can see here, this is for very small quantity of mix. From there, we move on to the tilting drum concrete mixer. And then from there, we can even order our concrete from these batching plants, which will send their trucks where the concrete is needed. So in terms of transporting the concrete, anything goes. Buckets, chutes, dumper truck, depend. If you are moving a small quantity of concrete horizontally or even vertically, you can use just a typical bucket. Or if you are moving the concrete in a larger volume and you are moving it vertically, you can use your chutes, or you can use your concrete pump. Okay, whatever goes. And during the transporting process, we must make sure there's not too much vibration and whatnot, because we want to avoid segregation. So these are some of the machines that can be used to transport concrete. As we know, we transport concrete in terms of horizontal and vertical movements. So in horizontal movement, we have a lot of machines and trucks and buckets and whatnot. To move it vertically, we can use the concrete pump, whether it's a mobile concrete pump or it's a fixed concrete pump, usually fixed to the structure itself. Or you can use very large iron buckets, which is connected to slings and connected to the crane. However, this method is not that efficient compared to the concrete pump. So in terms of the placement, the surface where usually it's the formwork must be clean, well prepared and watered. Must be near as practicable to explosion. So what this means is that when you want to place the concrete must be as near as possible to the formwork. We do not want to pour the concrete in a position where it is very far or very high from the formwork, because you might damage the formwork or even cause the formwork to fail. Because what we are pouring here is basically liquid rock. So we must pour it as close as possible to the surface where it is needed, in small quantity at a time to prevent uniform composition. So we pour it in small quantity and then we work it and then we pour it a bit more, or the process can be done simultaneously, depends on the volume. Okay, should not, and this I mentioned before, should not be dropped from high point. Deposit in horizontal layer maximum 600 mm. So meaning that every 600 mm after it's being poured, it needs to be vibrated and whatnot. And then we can pour in the second layer. It must be well worked around reinforcement. Okay, the reinforcement well worked into the crevices of the formwork, around the services, if there are any services in the concrete structure. So you have to make sure that there is not much, not any void being left in the concrete. Carry out uninterrupted between a predetermined construction joint. So meaning that when you start pouring concrete, you better keep on pouring. We do not want to stop unless it is a proper construction joint, then you can stop pouring at that point. So besides that, we do not want to stop pouring, because we have to remember that the concrete has to be built as one unit. So this is some of the images for placement of concrete. You can see here the worker here is vibrating the concrete to ensure that all the voids has been gotten rid of. Okay, so this is pouring concrete using buckets. Okay, Okay, so this is a small scale job, and this are again the bucket, usually being attached to a mobile crane or even a fixed crane. And these are the concrete, the mobile concrete pump. Next is the consolidation process. We mentioned this earlier. It's just this detail. So when the concrete has been poured, we want to ensure that we eliminate all the air bubbles in the concrete. Because these air bubbles, when the concrete has solidifies, will become a weakness, a point of weakness for the concrete. So that's why we need to do consolidation process. You can use, again, depending on the quantity, you can use hand consolidation, where you can see that the worker is basically bashing up the formwork lah. It's not really bashing, it's just knocking on the formwork to ensure that the concrete is poorly packed, is 100 like highly packed into the formwork, so there would be no air bubbles. But for larger scale jobs, you have to use the vibrators. So these vibrators, you can see this worker here is putting it between the reinforcement bars and all, because we want to make sure that the concrete is sufficiently covering the entire nooks and crannies between the reinforcement. We do not want to have any voids between the concrete and the reinforcement. Okay, so after the consolidation process has been done, the concrete will be left on its own for the curing process. As I said, the curing process will start as soon as the concrete has been properly mixed and being left undisturbed. So when the consolidation process happened previously, where we vibrate the concrete and whatnot, the curing process has not started as much. But once we leave it on its own, then the curing process will usually start to happen. So during this curing process, it's important that we keep the surface of the concrete wet. Wet doesn't mean here that we pour it with water. It's just we want to keep it moist so that the surface of the concrete does not dry out. Curing protects the concrete surface from sun and wind. So we do not want the curing process to happen too quickly. Okay. This will result in high stresses in the concrete, which will cause a lot of cracks. So we want the curing process to happen rather slowly, okay, so that we do not introduce a lot of stress to the concrete structure. So the surface needs to be protected from the sun, from the wind. So that's why we usually see on site the workers put in all these wet rags and whatnot to protect the surface of the concrete. Okay, this is mentioned already. Okay, proper curing increase the strength and properties of concrete. If this curing process been done properly, it will definitely provide a lot of advantages, especially in terms of strength to the concrete. So that's why in the factories they don't usually do this normal type of curing. They would also do steam curing, because this steam curing process will further improve the strength of the concrete being produced. So why it needs to be cured? Because we want to achieve a good quality of concrete. So a good quality concrete does not only depends on the grade, does not only depends on the workmanship, but it also depends on the curing process. As we know, this concrete works is a wet type of construction. So we want to ensure that the concrete does not dry out prematurely, because the absence of water will stop the curing process abruptly. So we want the curing process to happen until it is fully completed. In order to do that, there must be a presence of water. So if the water dries out too soon, then the curing process has been stopped prematurely. Okay, so by retaining moisture, it will build up strength and gain durability and resistance to wear. So the concrete needs to be kept continuously damp for at least 7 days. So the surface of the concrete needs to be a bit damp or a bit wet for at least 7 days to ensure that the curing process has been done completely. Okay, so if the curing process has been done completely, then we have the maximum strength of the concrete. So the easiest method is by cover the concrete with plastic sheeting after finishing. So you can cover it with anything, basically a rag or plastic sheet or whatnot, to keep the moisture in the concrete as the curing process happens. But steam curing is usually being done at the factory, so it's a lot more efficient than the method of just leaving the concrete to cure. So sound concrete is produced by mix, readily placed and compacted, good workability, free from void, and a good type of aggregate and water cement ratio. So ultimately, the properties of concrete that we use it so much is because it has a high compressive strength. You can try to compress this concrete as much as you want, but it will resist. The concrete does not corrode, and it hardens with age. So the older basically the older the concrete is, the more harder it gets. And it is economical compared to steel. So even though steel is good against both compression and tension, but still relatively a lot more expensive compared to concrete. And here in Malaysia, we do have a lot of supply for the ingredients of concrete. So we are a lot more used to concrete compared to steel. Okay, so weak in tension means that we have to introduce rebar. And concrete is also somewhat porous, especially if there is a lot of void in the concrete. So water tends to seep a bit into the concrete compared to steel. Okay, so that is a little bit on reinforced concrete. Next, we move on to other materials. Next is formwork. Okay, in terms of formwork, there's not much to say, but formwork is basically a temporary mold which wet concrete and reinforcement are placed to form a particular desired shape. So this formwork is a temporary work which we will basically take it off when the concrete has been properly cured. So in terms of materials, anything goes. You can use, usually for small scale projects, even medium size, they would use plywood and timber formwork. But for larger scale projects, they would use steel formwork because of the property of steel formwork can be reused again and again. Chipboard, we don't use that anymore. So in designing the formwork, there are several factors that you have to consider. First of all, the strength. The formwork must be built strong to receive the plastic concrete because the concrete itself is very heavy, especially when it is wet, because there's also the weight of the water inside the concrete. So a good formwork must be able to handle this load without buckling, meaning that we do not want the formwork to change its shape when we already put in the concrete. Okay, rigidity. Okay, it must have strength, it must be rigid. We want to prevent excessive deflection of the concrete. So we do not want the formwork to bulge up when we already put in the concrete. This would be very wasteful, meaning that the design will be flawed and we have to use a lot more concrete. Next is tightness. We do not want the concrete to leak through the formwork, especially through the joints of the formwork. Okay. Simplicity must be built as simple as possible because let's face it, it's just a temporary work. So we want to build it simple, easy to build, easy to be taken off. Okay, and fifth, easy handling. We want the formwork easy to be handled for the workers to work on the formwork. Okay, size must be a size that can be lifted into place without too much difficulty. Usually this is referring to the steel formwork. Usually the steel formwork is a lot bigger and it's a lot heavier compared to the timber. You can't actually, cut through the steel formwork to your heart's content. So we need some sort of lifting equipment, usually cranes, to work with steel formwork. But these days, there are also lightweight steel formwork. And then fit must be made to fit and fasten together with reasonable ease, especially for steel as well as timber formwork. Easy to remove. And then the quality must be good, especially in the interior surface of the formwork. It must be smooth as possible. And then safety, the formwork system must be able to handle the load of concrete, especially the wet concrete, people working on top of it, and all your equipment and machineries and its vibrations and all. And of course, the cost of formwork, depending on the type of project. If you just have a small scale projects, then your typical timber formwork would do just fine. But if you are doing larger scale projects, then you might want to consider steel formwork. So in terms of the design, it must be strong. It does not deflect as much. Okay, for usually the issues of deflections happens to the horizontal formwork because the gravity load that acts upon it is a lot more compared to vertical formwork. Okay, so as buildings, there are also two types of loads that acts upon a formwork. We have the dead loads, the load of the formwork, the load of the concrete, reinforcement, and the water, and of course the live loads, workers, and the equipment. So the pressure that acts upon a formwork, the concrete pressure, depends on, well, we know that the concrete is basically starts as it's not liquid per se, it's plastic. So it puts a lot of hydrostatic pressure upon the surface of the formwork. And the rate of placement, we want to put the or pour the concrete as close as possible to the formwork. And the temperature of the concrete during pouring process, we want it to be as low as possible. And then the vibration process, where we want to take out the voids from the wet concrete. So this will provide extra pressure on the formwork. And consistency of the mix, the aggregate and whatnot, the location of reinforcements would exert more load on certain part of the formwork compared to the other. So cost implication for formwork, of course, the higher the complexity, the higher the cost. Height above ground level, if the formwork is higher, means that it's gonna only get more expensive. Difficulty in placing and compacting concrete, usually this is because of the intricate design, so it will be a lot expensive. Repetition for the use of formwork, so the more you can use the formwork, the cheaper the formwork cost will be, because you do not need a new set of formwork. Standardization is important so that we can use the formwork at many parts of the building, and we can use it repeatedly. The formwork face must be protected. The smooth part of the formwork, we can apply all other substances to stop the surface of the formwork from sticking to the concrete. This is true for especially timber formwork. And then turnaround time, we want to have sufficient sets of formwork to ensure that the progress of work will be improved. But we do not want to have too much sets of formwork that it will be impacting the cost. And simple formwork design will prevent damage to formwork. Okay. So these are some of the systems of formwork. Okay, this formwork uses steel as the frame and some sort of timber. Okay, for the surfacing. This is typical formwork for concrete column, and this is steel formwork for RC wall. Okay. Right, so we are done with formwork. And lastly, reinforcement. So for reinforcements, we have two types. We have the mild steel reinforcement, which is this. And we have the high tensile, which is this. So the code for mild steel is R. Okay, it has a smooth surface. Compared to high tensile, the code is Y. It is deformed or it has a very rough surface. So this rough surface is important to ensure that the bars will bond better with the concrete. So for the steel bar reinforcement, we have a high carbon steel. So it's a very strong component. So beside the bar, okay, reinforcement bars, we also have fabric reinforcements. So fabric reinforcements come as rolls or pieces or sheets of fabric reinforcements. Okay. So as an example, the BRCA10, which is actually has a 10 mm diameter. Okay. So the square, okay, this squares is about 200 by 200. But the BRC B12, okay, the diameter is 12 and 8 mm, so it has two different sizes. Okay, that's the weight, a lot heavier. The rectangular shape is 100 mm times 200 mm. So different types of fabric reinforcement has different specifications. So as we know, the reinforcement bars has to be placed inside the concrete. So when we place the reinforcement bars in position, okay, we must space it from the surface of the formwork. So in order to do that, we can use a number of methods. That is known as the concrete cover, because as soon as the reinforcement is exposed to the air, it will obviously start to rust. So that's why we want the reinforcement to be inside the concrete. Okay. So proper spacing must be provided between bars to ensure concrete flows around bars and develop the necessary bonding. Okay, so the bars must be separated from each other. How far it is separated depending on the maximum size of the aggregate. The larger the size of the aggregate, the further the reinforcement bars needs to be apart. So if you are using a smaller type of aggregates, then your bars can be a lot nearer to each other. And of course, the size of the reinforcement bars. If you have a very large diameter reinforcement bars, you can afford to put it too close to each other. Okay, sufficient cover. We must protect the steel from the environment to prevent corrosion. And then the amount of cover provided depends on the type of environment. The thickness of the concrete cover depends on the environment. So the more extreme the environment is, the more concrete cover we need to provide to the reinforcement. And of course, the issue of fire protection. If you want to protect the steel from fire, you have to put in a lot more concrete cover, meaning that the reinforcement has to be placed deeper into the concrete structure. Okay, splicing, meaning that how do you join the reinforcement? Obviously, the reinforcement bar will come at a certain length. So if you need to elongate the length of your reinforcement bars, obviously you need to join them, okay, known as splicing. So this is to ensure the continuity of the structure, okay. So type of splicing, we have welded splices, meaning that between these two reinforcements we would weld it together. Mechanical splices, so these are joints which have special type of joint to join these two reinforcements. And of course they give an example here for the mechanical splices. We have a metal sleeve and couplers. So these are the metal sleeve and couplers that can be used to join the reinforcements. And of course the lap splices, these are the most common type of splicing, okay, and the most basic. Okay, the introduction of reinforcement steel in beams. Okay, reinforcement in beam is very critical because it gives tensile strength to the part of beam which is experiencing tension. So usually for beams, the part which is experiencing tension is usually at the bottom part of the bottom half of the beam. So this is where the concrete is experiencing a lot of tensional force, which it is not good at. So usually for beams, you can see that there will be a lot more reinforcement being put at the bottom half of the beam compared to the top. But this example is just the same. Okay. So by introducing a lot more reinforcement at the bottom half of the beam, the reinforcement will assist the concrete in handling the tensional force. And then to add compression strength to the portion of the beam, okay, this will adding reinforcement will also improve the compression strength of the concrete and the additional shear strength by introducing stirrups. So in placement of reinforcement, we have the main bar, which is this, okay, runs across the beam or the columns, and then we have the stirrups. So these are the stirrups. It will go around this main bar, okay, to provide against to provide strength against shear forces. Okay, you can see this is the main bar and these are the stirrups. So the function of reinforcing steel, okay, to absorb a portion of the loads and to provide lateral support and spacing. Okay. So requirement of bar reinforcement, it must have strength. It must be able to be bent into many shapes, so as we see here. And surface must be able to be bond with concrete. Similar coefficient of thermal expansion, meaning that when the concrete expands due to tremendous heat, the reinforcement must also be able to expand at the same rate as the concrete itself. If not, then we will have a lot of issues such as cracks and whatnot. So the rate of expansion between the bar reinforcement and the concrete must be somewhat similar. And then availability, so the bar reinforcement must be available in abundance in the market and at a reasonable cost. I don't know how reasonable it can be, because acquiring bar reinforcement can be quite expensive. So the schedules and details, usually in drawings and other documents, we can see there's a coding system being put for reinforcements. For example, 9R1201 at 300. So 9 meaning there is 9 numbers of bars or main bars in this group. 9. R is meaning that it means that it is a mild steel reinforcement. 12 here, 12, it means that the diameter of the mild steel reinforcement is 12 mm. 01 is the marking number. This is for bar number 1. At 300, meaning that the distance between those bars is at 300 mm, center to center. So what it's saying here is we have 12 mm diameter steel reinforcement bars, and we are referring to bar number 1. The distance is between those bars is 300 millimeter. So why concrete needs to be reinforced? We know that concrete only has the compressive strength. It does not have great tensile strength. So the difference here is like 10 times. Okay, so concrete can handle like 10 times the force of compression compared to the force of tension. So therefore, this is a weakness. To overcome it, we put in the reinforcement, because reinforcements not only strong against compression, but reinforcements are also strong against tension. So other reasons to spread the load evenly across the concrete components, to give shape, to reduce volume. By introducing reinforcement, we can reduce the volume and size of the concrete structure. Okay. For example, like ground beams. If you use mass concrete, obviously the ground beam will be a lot thicker if you compared to using reinforced concrete for your ground beam, because by using reinforced concrete for your ground beam, you can make the ground beam a lot thinner. And then the reinforcement also resists shear forces, and it can able to withstand shrinkages. Okay. So usually in reinforcement diagrams, we can see all these hooks, bends, and laps. It's here, this type of connections lah. So this bend, there's a hook, and all this. So what are these things for? So these hooks, bends, and laps are usually being done to the reinforcement to prevent bond failures. Okay, so bars should be extended beyond the section where there is no stress. So by doing these bands and whatever, it will help the reinforcement to attach to the concrete. Okay, so it also reduces the anchorage length at the end of the bars, and the length of band hook required will depend upon the grade of concrete. Obviously, the grade of concrete will affect the type of band or hook being produced. Okay, so that is it for today. We have covered the topics of reinforced concrete frame materials. We have covered concrete, formwork, and reinforcements. Okay, so if there's any issue, you can always contact me through whatever means, Facebook and WhatsApp messages and whatnot. I will try to get back to you as soon as possible. Okay, thank you for watching this live broadcast. Hopefully by next week we can resume our normal lecture. Okay. Okay, thank you all. Assalamualaikum warahmatullahi.